Okay, hello everyone. So in this video I'm going to solve a challenging problem which has three diodes. Okay, and what is required is to find the value of the V at this node and the value of the I in this branch, assuming that the diodes are ideal, which means that a diode is to be replaced with a short circuit if it is on and with an open circuit if it is off. How do we find out if it's on or off? If the Vp is greater than Vn, it is on. If the Vp is less than the Vn, then it is off. Alright? And if you want to solve this circuit in a systematic way, you have to search over 2 to the 3 equals 8 possibilities, possible combinations, and analyze the circuit 8 times. Alright? And find which one of them it has consistency among all diodes. Okay, only one of these circuits will be consistent. Why will be consistent? Why 8 possibilities? Because we have 3 diodes. Each one is either on or off. Okay, so only if it is consistent, in that case, then the circuit is the correct one. Okay. So, is there a possibility to find out the correct circuit without searching over this exhaustive search? The answer turns out to be no in general, at least not that I know of. But in simpler examples, sometimes it is doable, and this example is one of these examples. Okay. So in more general circuits, when it is 10 diodes and these high numbers, then in that case you might not be able to solve it using simpler methods. Okay, so I'm going to solve it at the moment, and I urge you to stop the video and find out how to solve this problem. Try to think about a way to solve it before watching the solution. Right? So how are we going to solve it? We're going to assume that we're going to look at the branch that has the highest potential difference among all branches. Right? So what's the value of the voltage here? That's negative 20 volts, that's negative 10, this is the ground, and that's 10 volts. Right? Which means that this 10 volts is the maximum voltage. Right? And the minimum voltage is negative 20, which means that this branch has the highest potential difference. Okay, while the rest of the branches, this is negative 10 and this is the ground, so this one has the highest potential difference. Okay, and this branch turns out to have a diode, right? And the diode D2 is going to be, we're going to solve for D2, we're going to find out whether D2 is on or off, assuming that the rest of the diodes are ignored, they are open circuit. Okay, and it turns out that this diode is going to be on, because the Vp is closer to the 10 volts and the Vn is closer to the negative 20, right? Assuming that those two diodes are off, okay? What is the value of the voltage at that particular case? It is negative 5 volts. Why? Because the 10K is going to have pretty much a value of the voltage the same as the value that this is going to take. So the voltage, the 10 and the negative 20, that's 30 volts of potential difference. 15 here and 15 here, so that's negative 5. Why am I going to assume that this is always going to be on when D2 and D3 are off? I mean, what happens if they're on? Even if they're on, I guarantee that this is going to be on as well. Why? Because in order for this to be off, in order for this diode to be off, you have to have this value smaller than negative 20, and that's impossible. You can never have negative 20 out of this circuit. These two are higher than negative 20, negative 10 and 0 volts. Okay, so I guarantee for sure that this diode is going to be on, because this cannot be lower than negative 20 volts. Okay, so what about so that's why I'm going to replace this with a short circuit. Okay. Okay, and D1 and D3, I'm going to switch them on one by one and see what is going to happen. Okay, so D1, we know that D1 is going to be was off. Right now we're going to assume that it is on. We're going to switch it on, right? And in order for it to be on, this value, we know that this is negative 5, and this value has to be smaller than negative 5, so like negative 6 or negative 7. And this is possible, that comes from the negative 10. Okay, And if that's the case, then this is going to be on. We really do not know for sure if it's going to be on or not. But if this value is -5 and this value happens to be smaller than -5, then in that case this diode is going to be switched on. Which means that if this value is -5, which means that this value is going to be -5. Why? Because once this is switched on, that's a short circuit, and this value is going to be -5, which makes this -5, which makes this diode on as well. Right? Why? Because that's Vn is smaller than the ground, negative. Which means that this is going to be a short circuit. So this value is going to come back to the 0. Right? And thus this diode is not going to be on. Right? And which means that this is going to be, this diode is going to be on, turning this back off again. Okay? And in that case, this is going to be 0, and the current passing through, and so this is going to be 0, and this is going to be off, right? Because that's a negative potential difference, and the current passing through here is going all to pass to the -10. Okay? And thus this is going to be off, okay? And this is going to be on, okay? Which means that the current is going to pass here, and thus nothing is inconsistent as we can see. Okay? So if you solve the potential difference, that is the current passing here, that comes from the 10 volts, is going to pass to the -20, and nothing is going to pass here, alright? While the current that passes through the D3 is going to pass from the high voltage, which is the ground, to the low voltage, which is the negative. That's a total of 10 was 1 milliampere. Okay, I equals 1 milliampere, and the value of the voltage here is -5. Remember that the diode D1 was in this orientation, so VP equals -5, while Vn equals 0. VP is larger than Vn, which means that it is off, and this is consistent with the assumption. Alright? So that's quite a kind of a challenging problem, and it's not easy to figure out this solution, but there are some tricks and some ways to kind of find out which out of the 8 possibilities is the correct possibility. It becomes much easier if you have only 2 diodes, and if you really want to solve another problem, I urge you to solve this problem. Okay, that's D1, and that is D2, and this diode is reversed. Okay, what if this diode is reversed? If that's the case, you can figure it out. There is another way of solving the problem. You can go over the steps that I have went through. A little bit of differences might happen, but you will be able to figure it out. Right? If you have any questions, if you have any problems that are not easy to solve, please post them and I'll be happy to answer them.